And so ultimately, it's because fusion technology will have some inherent hazards that may warrant regulation and different levels of regulatory oversight. So if we think about a DT fusion machine, you can think about the radioactive tritium that goes into it is a radiological hazard. The deuterium's not. And then as we think about what comes out of the fusion machine, you've got neutrons, which are a form of radiation that can cause harm, and the helium, perfectly fine. But the problem is that neutron can do a couple of other things. It can create activated materials by causing things that it interacts with to become radioactive and become hazardous. And it can also create secondary radiation through its interaction with other particles. And so the challenge here really ends up becoming, we have to address what all of these different hazards are going to be and try to determine the magnitude. And so if we take a look at fusion technology at a very broad scale, you can think of a variety of different radiological hazards and also a variety of different industrial hazards that would have to be managed. But the reason that I say may on this slide is very intentional. Because ultimately, when you talk about any hazard and you talk about any technology, it comes down to magnitude and it comes down to risk.